here Lalita ma'am is in front of you with another topic, that is about P block elements we were discussing. Even in the previous video we have discussed about what? Group 13, 14 and 15 group elements. Okay, their properties, okay, and compounds which are related to that block elements, okay, and properties and all, okay, oxidation states and all we have discussed. Same like that, in this video also we are going to discuss about the remaining groups which are left over. Those are what? 16, 17 and 18 group elements. Okay, now so today our topic is what? P block elements part 2. Okay, now P block elements part 2. Okay, now so in this video we are going to discuss about what group of elements? About 16, 17 and 18th group elements. Okay, now 16, 17 and 18th group elements. Okay, so if you speak about group 16, okay, so group 16 elements are what? Oxygen family. Okay, oxygen family. 60A group elements are called as 16th group elements. 60A group elements. Okay, they are called as what? Oxygen family. Okay, oxygen family. So these are also called as chalcogens. Okay, now these are also called as what? Chalcogens. Chalcogens, the word chalcogens stands for what? Ore forming elements. Okay, now ore forming elements. Most of the elements of 60A group are meant for forming certain metallic ores. Okay, now they exist in the form of ores. Okay, ore forming elements. I think you have idea about ores. Ores are the substances from which metals can be extracted economically and profitably. Okay, now from which you can extract metals, you call them as what? Ores. Okay, without any economical loss, if maximum extent of metal if you can separate, then the substance from which you can separate metals without any economical loss, you call that substances as what? Ores. So ore forming elements, chalcogens are what? Ore forming elements. Like you can take example, the 60A group elements are what? Oxygen. As they are oxygen family members, first member of this family is what? Oxygen. Sulfur, selenium, tellurium and polonium. Selenium, tellurium and polonium. So these elements are called as what? 60A group elements. Why they are called as 60A group elements? They have general configuration NS2 NP4. Okay, now general outermost configuration is what? NS2 NP4. That's why you call them as what? 60A group elements. Okay, so in this oxygen, sulfur, all these are ore forming elements. Like you can take any metallic ore, like bauxite. If you take bauxite, is an ore of aluminium which exists in the form of what? Al2O3. Al2O3.2H2O is an oxide ore of aluminium. So in this oxygen is there, which is meant for what? Forming that bauxite ore. Okay, isn't it? Aluminium oxide is called as what? Bauxite ore. Ore forming elements. Okay, same like that hematite, Fe2O3.2H2O, hematite. Okay, hematite, magnetite, Fe3O4. Okay, now magnetite. All these are what? Oxide ores, where oxygen is considered to be the main element which is there in that ores, magnetite. Okay, even sulfide ores are also there. We have sulfide ores like what? PBS, galena is there. Lead sulfide, galena is there. Okay, mercuric sulfide, cinnabar is there. Okay, so like this, all these are what? Ore forming elements. Here sulfur is there. Sulfur is forming an ore of mercury, which in other words you call it as what? Ore form. Cinnabar. You call it as what? Cinnabar. Okay, like this, chalcogens, the word stands for what? Ore forming elements. Okay, so 60A group elements are considered to be what? Ore forming elements. Okay, so let us learn about their properties and general physical and chemical properties of 60A group elements. We have to learn about them. Okay, so mainly if you go for the occurrence. You all know the first most element of 60A group elements is what? Oxygen. Oxygen is the very much essential element for human beings, isn't it? Oxygen. Oxygen is the most abundant element among all the other elements, even in the earth's crust also, or even in the atmosphere also. Okay, now oxygen, the most abundant non-metal. Oxygen is what? Non-metal. Okay, the most abundant non-metal. Okay, it is there even in atmosphere also, and even under the earth's crust also. Under the earth's crust, you are finding that in the form of what? Ores, oxide ores. Okay, and then you have what elements are there here? Oxygen, sulfur, selenium, tellurium and polonium. Okay, oxygen and sulfur are what? Non-metals. Okay, oxygen and sulfur are non-metals. In that, oxygen is gas, whereas sulfur is a yellow colored solid. Okay, now sulfur is yellow colored solid substance which appears in the form of powder. Okay, and then selenium and tellurium are what? Metalloids. Selenium and tellurium are what? Metalloids. And polonium is a metal. Okay, which is considered to be what? A radioactive metal. Polonium is radioactive metal. Okay, so this is the physical characteristics, physical existence of that 60A group elements. Okay, so in that, the most abundant non-metal is what? Oxygen. Okay, sulfur is also present in most of the cases, in most of the substances, and you all know that sulfur is the element which is present in onions. Okay, because of release of sulfur. Okay, our eyes gets burnt if we are cutting onions. Okay, so and it is also present in eggs. Sulfur is the next non-metallic element which is present in 60A group elements. Okay, it is present in eggs, onions, garlics, mustard. Okay, it is present in what? Rich source of sulfur is there in eggs. Okay, it is there in onions, garlic also it is there. That's why a kind of pungent smell will be there for onions as well as for garlic, and even egg yolk also consists of what? Sulfur will be there. Okay, so it is like a rich source of protein which is there. It's a mineral actually. Sulfur exists in the form of mineral. Okay, and next, if you go for the periodic properties, you all know that atomic size increases down the group. Okay, in atomic size always increases down the group because of extra energy shell. Electrons gets added into what? Next coming orbits. Atomic size increases down the group. Okay, now atomic size increases down the group. Ionization energy also decreases down the group. As atomic size increases, ionization energy decreases. You know that point. Okay, ionization decreases down the group. And if you speak about electronegativity, okay, oxygen is the second most electronegative element. The first most electronegative element is fluorine. Next to fluorine, the most electronegative element is what? Oxygen. Okay, so electronegativity decreases down the group. Electronegativity decreases down the group. Okay, and oxygen is the most electronegative element. Oxygen. Okay, second most electronegative element. Okay, first most electronegative element is what? Fluorine. Please remember that point. Okay, second most electronegative element. So electronegativity of oxygen, okay, plays a very important role in the formation of many compounds. Okay, and next, if you go for electropositivity, generally for non-metals, electropositivity will be very less. Tendency to lose electrons will be very less. Okay, so electropositivity, what happens? Increases down the group. It will be very less for oxygen and it will be high for polonium, because polonium exists in the form of what? Metal. Down the group, I already told you, bottommost element is a metal. Okay, so electropositivity increases down the group. And electron affinity is what? The energy released when an electron is added to the valence shell of neutral gaseous isolated atom. You call it as what? Electron affinity. Okay, electron affinity also decreases down the group. Like electronegativity, electron affinity also decreases down the group because it is the property of what? Non-metals. Okay, electron affinity, electronegativity, these are the properties of what? Non-metals. Okay, so electropositivity positivity increases, affinity and electronegativity decreases down the group. Okay, so this is about periodic properties of that group elements. Okay, and next if you go for physical properties, okay now, physical properties not all this. If you go for chemical properties, okay now, the chemical properties of certain elements of 6A group. Okay, then you all know that oxygen and sulfur are non-metals, as I told you. Okay, these properties other than physical properties, you have other properties like these elements even exhibits the property of what? Allotropy. You know that what is allotropy? Allotropy is existence of same element in two or more different forms is called as allotropy. Okay, same element but exist in different forms, as how you have learnt in case of 4th A group elements. Carbon exhibits so many allotropic forms like diamond, graphite, C60, Buckminster fullerene, like that it has existed in so many forms. So allotropy can be exhibited even by what? 6th A group elements also. Okay, so allotropic forms of sulfur, if you go for, okay, what are the allotropic forms of sulfur? Rhombic sulfur. Okay, sulfur exhibits allotropic forms like what? Rhombic sulfur, monoclinic sulfur, okay, monoclinic sulfur, and plastic sulfur, and flowers of sulfur. Like that you have different forms of allotropic forms of sulfur, flowers of sulfur. Okay, if you are heating sulfur in different temperatures, okay, then different allotropic forms of sulfur can be exhibited by that particular element. Okay, sulfur, okay na, atomic number is what? 16. It's a yellow colored powder. Okay, solid powder. Okay, it's a non-metal. It exhibits the properties of what? Non-metal. Okay, so if you go for oxidation states, okay, next important property exhibited by 6th A group elements is what? Oxidation state. If you go for the oxidation states of 6th A group elements, okay, oxidation states of 6th A group elements are what? +2. Generally, oxygen exhibits -2. Okay, oxygen exhibits -2 oxidation state. Okay, in most of its compounds because of its high electronegativity, and -2 for oxygen. Please remember this point. Oxygen in most of the cases it exhibits -2 oxidation state. Okay, because of what? Because of high electronegativity and small size. Because of high electronegativity. Okay, because of high electronegativity and small size, oxygen exhibits what? -2 oxidation state. In most of the compounds, okay, oxidation state of oxygen is what? -2. Okay, for other elements, what about other elements like sulfur, selenium and all? Okay, they exhibits the oxidation state of even +2 also, -2 also, +4 also, and +6 also. Okay, +6 oxidation state also can be exhibited by most of the elements of 6th A group. Okay, so +2, +4 and +6 oxidation states. Other elements, for other elements it can exhibit what? +2, +4 and for other elements OS. OS means what here? Oxidation state. Oxidation state is +2, +4 and even +6 oxidation states also 6th A group elements can exhibit. Okay, so like that it exhibits higher oxidation states also. Okay, so and next if you go for the properties like stability of +4 oxidation state increases and stability of +6 oxidation state decreases down the group. Okay, remember, write it as a note point. Stability of +4 oxidation state. Okay, +4 OS. increases and +6 oxidation state decreases down the group. Okay, +6 oxidation state stability decreases down the group. This is due to what? Already I told you, even in the 15th group elements also. That means even in the nitrogen family also, the same point we have learnt. Okay, actually substances with higher oxidation state will be more stable than substances with lower oxidation state. But as you go down the group, because of inert pair effect, please remember the point, because of what? Inert pair effect. What is inert pair effect? The reluctance of NS electrons to participate in bonding. They are not interested to participate in bonding. So because of that reason, what happens? The element with higher oxidation state, okay, it becomes less stable than the elements with the lower oxidation states. Okay, now, so as you go down the group, the stability of +6 oxidation state decreases. Okay, and +4 only will be high down the group. Okay, so you have to remember this point. Okay, stability of oxidation states of different groups of elements. Okay, and next step, if you go for hydrides, okay, hydrides, they form hydrides of type MH2. Okay, they means what? Elements of 16th group, they form hydrides of type what? MH2, where M is what? M is 6A group element. M can be oxygen, it can be sulfur, it can be selenium, tellurium and polonium. Okay, polonium, however, it is radioactive element, so I am not writing that. So MH2 type oxides. Here if you write O in place of M, OH2 means H2O. Okay, now generally we write hydrogen first and then the non-metallic element, the other non-metallic element. So water is the hydride of what? Oxygen. Same like that H2S, hydrogen sulfide. Okay, H2Se. Okay, hydrogen selenide, H2S, H2Se type of oxides they will form. Okay, sorry, hydrides they will form. So if you go for the hydrides, acidic character increases from water to H2TE. See here, H2O, H2S, H2Se, H2TE. Like this hydrides are there. Okay, so like this you will find what? Acidic nature. Okay, acidic nature increases from, acidic nature increases, actually increases. Acidic nature increases from water to H2TE. Okay, water is less acidic, H2TE is more acidic. Actually water is neutral. You know that water is neutral, more acidic. So what happens from top to bottom in a group? Acidic nature increases. Okay, now from top to bottom in a group, acidic nature increases. Please remember this point. And you know that hydride of oxygen, that is water, is what? Neutral substance. Okay, now, so this is about acidic nature of hydrides. These orders, most of the times these orders are being asked in the EAMCET type of questions. So please go through such kind of orders. Okay, and next if you go for thermal stability. Okay, thermal stability decreases from water to H2TE. Okay, if you go for thermal stability, that means what? If you are heating that particular substance, okay, thermal stability. Okay, what happens to thermal stability? Thermal stability of hydrides of 6A group elements decreases from water to H2PO. It decreases from H2O to H2O, means water to H2TE. H2TE means what? Tellurium hydride. Okay, now tellurium hydride, H2TE. So thermal stability decreases. Water is only considered to be more stable. Even if you are heating water or boiling water, okay, it can remain stable. It can remain in the stable state. Whereas if you are heating H2TE, thermal stability decreases. Okay, so it decreases. Thermal stability decreases from water to H2TE. Okay, And then reducing property increases. Reducing property. If you go for reducing property, increases. Reducing property increases from water to H2TE. Okay, now H2TE. Okay, so instead of if you go for water, okay, directly, better you go with H2S. H2S reducing property will be high. Okay, and H2TE reducing property will be more high. Okay, so reducing property increases from hydrogen sulfide to hydrogen tellurium hydride. Okay, and next they form oxides of type MO2 and MO3. See here, next point which is you have to remember is what? They form oxides of type MO2. Okay, they form oxides of type what? MO2 and MO3. Okay, they form oxides of type MO2 and MO3. Okay, and these oxides are what? Acidic in nature. These oxides are acidic in nature. Please remember these points. These oxides are what? Acidic in nature. Okay, generally non-metallic oxides are what? Acidic. Metallic oxides are what? Basic. Okay, if you go for these 6A group elements, you are finding most of the non-metals. Okay, you are finding only polonium is a metal. Okay, selenium, tellurium, of course they are metalloids. Okay, so if you go for their oxides, they exhibit what? Acidic character. Very weak acids, but still they exhibit what? Acidic character. Okay, so generally the oxides of this group elements are what? Acidic in nature. Please remember that point. Okay, and reducing property decreases from SO2 to TeO2. Reducing property of oxides. Reducing property decreases. Okay, now reducing property decreases from SO2, sulfur dioxide, you know, SO2 sulfur dioxide to tellurium oxide. TeO2, tellurium oxide. Okay, reducing property decreases from sulfur dioxide to tellurium oxide. Okay, and next they can form halides. Okay, halides of what type they can form? MX2 type, MX4 type halides they form, and even MX6 type halides also they form. Halides means what? With halogens, means with 7th A group elements. Okay, they form halides. Okay, so these are the general properties which are exhibited by what? 6A group elements. If you go for the compounds of 6A group elements, okay, if you go for the compounds, the first and foremost thing which you have to discuss is about ozone. Okay, now ozone, compounds of oxygen if you go for. Okay, generally oxygen you know, compounds of oxygen, first one is what? Dioxygen we say, compounds of oxygen. Okay, in that first one is what? O2. You know O2 is a double bonded molecule. Okay, oxygen is having atomic number 8, electronic configuration 1s2, 2s2, 2p4. So valence electrons are 6, that's why it is a 6A group element. You know that. So if valence electrons are 6, okay, it requires 2 more electrons for octet. So it will share with the second oxygen atom and forms what? Octet configuration. So here 2 pairs of electrons are shared. That's why it is called as what? Double bond. Double bonded compound. Oxygen is what? Double bonded compound. If double bond is there in between two elements to form a compound, okay, if double bond is present, then you all know that it is one sigma bond and the other one will be a pi bond. So oxygen molecule, how does an oxygen molecule is formed? Means by sharing 2 pairs of electrons with each other. Okay, if you go for preparation, okay, preparation of oxygen, laboratory preparation of oxygen if you go for, okay, generally oxygen can be obtained by thermal decomposition of certain carbonate salts, okay, and thermal decomposition of certain chlorate salts, okay, potassium chlorate, potassium permanganate if you are going to heat them. Thermal decomposition will happen and you will be getting oxygen gas. Okay, now preparation, laboratory preparation, how they will do? Potassium chlorate 2 KClO3 on heating, it gives rise to what? 2 KCl plus 3 O2. Okay, so like this oxygen gas is liberated by thermal decomposition of what? Potassium chlorate. KClO3 means what? Potassium chlorate. Okay, so here oxygen is liberated. Even if you take potassium permanganate, KMnO4, you know it is a pink colored salt, potassium permanganate. Okay, potassium permanganate, if you are going to decompose it, okay, potassium manganate, manganese dioxide and oxygen also you will be getting. Potassium KMnO2 you will get, manganese dioxide you will get, and oxygen also you will get. Okay, so if you take this reaction, okay, 2 KClO3, generally it requires almost around 300 degrees centigrade. Temperature required is what? 300 degrees centigrade temperature you have to heat that potassium chlorate. But if you are taking manganese dioxide as catalyst, MnO2 if it is taken as catalyst, okay now, MnO2 if it is taken as catalyst, then the reaction can happen. That means release of oxygen gas can be obtained even at 240 degrees centigrade only. You need not to heat it up to 300 degrees centigrade. In presence of what? Manganese dioxide as catalyst, liberation of oxygen gas can be obtained at 240 degrees centigrade only. Okay, so here manganese dioxide acts as what? Catalyst. Okay, here how can you say that the gas liberated is oxygen only? Okay, oxygen is a colorless gas, odorless gas. It is not having any color. Then how can you say that the gas liberated is oxygen only? How can you test the presence of oxygen gas? You all know that oxygen is a good supporter of what? Yes, it's a good supporter of combustion. So combustion means what? Burning. Okay, burning of any substance in presence of oxygen. You call it as what? Combustion reaction. So oxygen is the best supporter of combustion. If you take a burning or a glowing agarbatti, okay, and if you keep that on the top of the test tube in which the reaction has been done, okay, if you are heating potassium permanganate, then also oxygen is liberated. If you are heating potassium chlorate, then also oxygen is liberated. If you just keep a glowing agarbatti in the on the top of the test tube in which the reaction has been performed, okay, then that agarbatti catches fire and glows more brightly. Okay, so that is the test for oxygen gas. What is the test for oxygen gas? Burning splinter burns more brightly. Burning splinter means what here? If a burning splinter burns more brightly, okay, then you call that as what? Test for oxygen gas. Because oxygen is a good supporter of what? Combustion. Oxygen is a good supporter of combustion. Okay, good supporter of combustion reaction. Okay, so like that testing, how to test an oxygen gas. And even oxygen can be obtained by thermal decomposition of certain oxides. Okay, and decomposition of hydrogen peroxide also gives you oxygen gas. Certain oxides like silver oxide, lead oxide, on heating they gives oxygen gas. Okay, so preparation of oxygen gas once you go through. Okay, so like that. And next we go for what? Next compound of oxygen. Next compound of oxygen if you go for, okay, it is ozone. Okay, uses of oxygen and all, you have certain uses. Once you check with the textbook, you have your NCERT textbook is there with you, so you can check with that. Okay, next we go for what? Okay, next we go for ozone. Ozone is also a compound of oxygen, and even you can say that it is an allotropic form of oxygen. Ozone. Okay, now ozone O3. Okay, So how this ozone is formed? You all have idea that it is formed. It is there in atmosphere, okay, and protecting our earth from hot sun, or the UV rays that are coming from sun are being, we are protected from UV rays that are released from sun, ultraviolet rays that are being released by the sun. We are protected by them with the help of this ozone layer. Ozone layer is there around our surface of the earth. Okay, earth surface, it is there. Okay, so it is protecting us from hot UV rays which are coming from sun. Okay, so it's an allotropic form of oxygen. Okay, so now you have to study the properties of ozone. Okay, now what are the different properties exhibited by ozone? Okay, so as you have studied, ozone is highly reactive and forms atmospheric oxygen in presence of sunlight. Okay, it's a highly reactive substance. Okay, it is a highly reactive substance. Okay, now highly reactive. Ozone is considered to be what? Highly reactive substance. Okay, highly reactive substance. Even then, it protects us from what? The UV rays that are coming out from sun. Okay. And what about the other properties exhibited by ozone? Okay. It exists in the form of pale blue colored gas or dark blue colored liquid, violet black solid. It can exist in three forms. It exists in the form of, it exists as pale blue colored gas. Okay, now pale blue colored gas. In the form of gas, it exists like what? Pale blue colored gas. Okay, and it can also exist in the form of dark blue colored liquid and violet black colored solid. Dark blue colored liquid, okay, dark blue liquid, and in the form of solid it can exist like what? Violet black colored solid. Violet black solid also. Ozone can exist like three forms. Okay, now pale blue colored gas. In the form of gas, it is exist in the which color? Pale blue colored gas. Okay, so next, high concentration of ozone may leads to explosion reactions. Okay, high concentration of ozone leads to what? Leads to explosions. High concentration of ozone can leads to explosion reactions. Okay, can leads to what? Explosion reactions. Okay, yes. And next we go for what? If you go for if you go for its actual other properties which are being asked in your EAMCET exam. Okay, it acts as a very good oxidizing agent. It acts as, ozone acts as very good oxidizing agent. Okay, now very good oxidizing agent. What is oxidizing agent? The substance which undergoes reduction is called as what? Oxidation. Oxidizing agent. Okay, the substance which undergoes reduction. Reduction means what? The substance which gains electrons is said to be performing the process of reduction. Reduction means what? Gain of electrons. Okay, or removal of oxygen or addition of hydrogen. Anything you can call it as what? Reduction. So substance which undergoes reduction is considered to be what? The best oxidizing agent. So ozone is considered as what? Best oxidizing agent. Okay, it acts as a powerful oxidizing agent. Okay, and oxidizes lead sulfide to lead sulfate. It oxidizes lead sulfide means what? Galena. Oxidizes lead sulfide to lead sulfate. Lead sulfide is what? Galena, PBS. Okay, lead sulfate. Lead means what? Plumbum. Okay, so PbO. Okay, in presence of ozone, PbO, Lead sulfide is what? PbS, galena. You call it as what? Galena. In the ore form, you call it as galena. Lead sulfide, galena, okay, in presence of ozone, in presence of ozone gas, it gets oxidized to what? Lead sulfate will come, PbSO4. Sulfate will be what? SO4. And along with that, you will get even oxygen also. Okay, so it oxidizes lead sulfide, galena. Galena is what? The sulfide ore of lead. Pb means what? Lead, plumbum. Okay, so plumbum, like that it oxidizes, and even it oxidizes certain metals like mercury and, okay, it oxidizes certain metals like mercury and silver. Oxidizes metals like what? Mercury means Hg, and silver also, Ag. Okay, so Ag plus O3. So it gets oxidized, silver gets oxidized. Normal oxygen, atmospheric oxygen won't react with the normal oxygen, Ag2O, and here you will be getting oxygen gas also. Okay, normal oxygen does not react with the noble metals like silver and platinum and mercury. Okay, that's why corrosion will not happen for noble metals. Corrosion means what? Formation of oxide layer on the surface of certain metals. Now if you take metals like silver, okay, and mercury, if you take, mercury is what? Hg. Hg plus O3. See here, silver and mercury are reacting with ozone, but they are not reacting with normal oxygen. Okay, they are less reactive. Okay, now these metals are what? Less reactive. They are present in the bottom of the reactivity series. Okay, so they are less reactive. So Hg2O. Hg2O will form. Okay, Hg2O plus O2. Okay, so like that ozone can oxidize certain metals. Okay, Hg2O loses its meniscus. Here Hg2O, you know that mercury is a substance which will not have free flow like normal liquids. Okay, now I think you might have idea about mercury. Okay, so here what happens is, when Hg2O is formed, it loses its meniscus and gets stick to the sides of the glass. Actually, meniscus, do you know? It loses its meniscus. Do you know what is meniscus? Okay, the surface of any liquid, if you can see from the test tube. Okay, if you see in a test tube, okay, generally mercury does not stick to the walls of a test tube. Okay, meniscus means what? You will find the substance, top of the substance, surface of any liquid. If you observe through the borosilicate glass with which that test tube is made up of. Okay, the test tube is made up of what? A kind of glass called as what? Borosilicate glass. Even in the previous P block elements, that is in silicates group. Okay, in carbon family already we have learnt glasses, types of glass I said you to learn. Okay, types of glass. Okay, like pyrex glass, flint glass, borosilicate glass, like that you have different types of glasses are there. Okay, so if you are taking mercuric oxide in a test tube, generally if you take only mercury does not stick to the walls of the test tube, or it does not stick to the walls of the does not get stick to the walls of the thermometer also. That's why you all know that mercury is being used in what? Thermometric liquid. It is a thermometric liquid. It does not stick. Okay, and it forms meniscus generally. Meniscus means what? That edge, exact edge you can find. If you have readings on the test tube, you can find the volume of that particular substance by seeing the meniscus. Okay, meniscus means it's a surface layer which forms on the surface of that particular liquid. You call it as what? Meniscus. Okay, so here what happens is Hg2O loses its meniscus, means it does not appear as if some demarcation is there. Okay, it does not appear as if some demarcation is there. Okay, so it loses its meniscus, and you cannot even judge that mercuric oxide is present in that test tube. It's a transparent glass test tube you have taken, and in that mercuric oxide you have taken. Okay, normally if you take only mercury, you can see that mercury is like a thermometric liquid, you can see. But mercuric oxide, what happens? If you are keeping that in a test tube, it loses its meniscus. Okay, na HGO, Hg2O, if you take in the test tube, it loses its meniscus. Okay, loses its meniscus. What is meniscus? The surface layer, meniscus, and does not stick to the walls of this test tube. Does not stick. Okay, does not stick to the walls of the test tube. Okay, and this phenomenon, you call it as what? Tailing of mercury. You might have heard. This phenomenon is called as what? Tailing of mercury. Okay, does not stick to the walls of the test tube. You call it as what, Nano? Tailing of mercury. Okay, Hg. Tailing of mercury. This sometimes they are asking in the EAMCET questions. Okay. Process of meniscus, loss of meniscus by formation of what? Hg2O. Okay, when Hg reacts with what? Ozone. Okay, this is called as what? Tailing of mercury. Please remember that point. Okay, and next we'll move on to like if you go for hydrocarbons, ozone when reacts with alkanes or alkynes, okay, they form what? Ozonides. Okay, ozone, remember ozone when reacts with hydrocarbons like alkanes. Okay, ozone when reacts with hydrocarbons. Ozone when reacts with hydrocarbons, it forms what? Ozonides. It forms ozonides. Okay, it forms ozonides. Okay, please remember that point. What are ozonides here? Ozonolysis. The reaction is called as what? Ozonolysis. The reaction is called as what? Reaction is called as ozonolysis. Okay. So you take any hydrocarbon here. If you take like C2H4, ethene, if you take C2H4, ethene. Okay, when reacts with ozone, okay, it forms what? Ethylene ozonide it forms. Okay, ethylene ozonide, CH2, oxygen. Okay, this kind of substance you will find. Okay, this is called as what? Ethylene ozonide. Ethylene ozonide is the substance which is formed. And this reaction you call it as what? Ozonolysis reaction. Okay, so this is about what? Ozone, reactions of ozone. And you already have learnt that because of the release of certain CFCs. What are CFCs? CFCs like chlorofluorocarbons and all, high reacting pollutants they are. Okay, industrial gases and all, they'll be releasing what? Freons. Okay, now, and they'll be releasing certain poisonous gases which remain suspended in the atmosphere. Okay, and that you call it as what? Suspended particulate matter. Okay, SPM you call it as. Okay, so here why I am saying about them? Certain pollutants like CFCs and chlorofluorocarbons, okay, are also leads to the formation of what? Leads to the formation of depletion of ozone layer. Okay, depletion. What is meant by depletion? Depletion of ozone layer. Okay, here why it is getting depleted? Means you are observing holes are formed on the ozone layer. Okay, because of that reason only global warming is increasing. Why it is happening like that? Because of the release of certain aerosol sprays we are using. We are using ACs, fridge and all we are using. So from all these electrical appliances, okay, they release what? Certain poisonous substances called what? CFCs. Okay, now release of CFCs into the atmosphere. Release of CFCs. What are CFCs? Chlorofluorocarbons. Chlorofluorocarbons. Because of the release of CFCs into the atmosphere, ozone layer is getting depleted. Okay, it is for our comfort zone. Okay, we use AC in our houses. Okay, air conditioner will be there, refrigerators will be there, okay, compressor will be there in them. So by the usage of that compressor continuously for long time, okay, what happens? They release chlorofluorocarbons into the atmosphere. Okay, that chlorofluorocarbons are leading to the depletion of what? Ozone layer. Ozone layer is getting depleted. It is forming holes. Ozone layer is forming holes because of the release of these poisonous gases into the atmospheres. Okay, that's why we are suggested to use what? ACs and refrigerators to the minimum extent. Okay, without that our work will not happen, I think so. Most of us will sit in AC only during summer season. Okay, so like that, usage of electrical appliances releases poisonous substances called CFCs into the atmosphere. This leads to the depletion of ozone layer. Okay, so because of this depletion of ozone layer, what is happening? Global warming is increasing. Okay, temperature is increasing, Earth's temperature is increasing. So ultimately what should be the remedy for this? Yes, the remedy for this is planting trees and usage of certain electrical appliances like AC and refrigerator has to be used less. Okay, so you have to follow these techniques. Okay, so depletion of ozone layer is also one of the important point which you have to remember. Okay, and if you go for the structure of ozone, okay, structure of what? Ozone it is O3, right? O3 means there is a double bond in between two oxygen atoms and there is a coordinate covalent bond for the third oxygen atoms. Okay, oxygen generally has how many valence electrons will be there? 6 valence electrons. Okay, oxygen will have what? 1, 2, 3, 4, 5, 6 valence electrons will be there. Okay, so it requires more 2 valence electrons for obtaining octet configuration. So when it forms a bond, okay, first oxygen will form, okay, a double bond with the second oxygen atom, and here you have already 2 lone pairs are there. So there is no wrong in donating 1 lone pair to the third oxygen. Okay, so like this, ozone will have 1 double bond will be there and 1 single bond will be there, and this can be even interchanged also. That means resonance structures can be exhibited by ozone molecule. Okay, so you can even take the single bond to be in between first 2 oxygen atoms like this, and this double bond can be shifted to the third oxygen atom also. Okay, so you can even draw the structure of what? Ozone even like this also. Okay, so accordingly you will have a canonical structure. I mean resonance hybrid structure can be drawn like this, resonance hybrid structure. Okay, so dotted line you will draw in between the oxygen atoms. You will draw a dotted line, okay, which indicates that this double bond can be either pi electrons can be shifted. You call it as what? Resonance phenomenon. Okay, so resonance hybrid structure will be exhibited by ozone also. Okay, generally this double bond can be shifted either from here to here, so that resonating structures will come. Okay, so ozone molecule is undergoing what? Resonance structures. Okay, resonance phenomenon can be observed in ozone molecule. Okay, so this is about what? Ozone, or compounds of what? Compounds of oxygen, uses and all once you go through. Okay, next if you go for sulfur, okay, compounds of sulfur. Okay, next if you go for compounds of sulfur, okay, I already told you sulfur exhibits allotropic forms. Okay, compounds of sulfur. Okay, so if you go for compounds of sulfur, okay, sulfur exhibits what? Allotropic forms like rhombic sulfur, monoclinic. Okay, allotropes will be there, rhombic, monoclinic and plastic. Okay, rhombic, monoclinic and plastic. 3 types of allotropic forms are there for sulfur. Okay, so rhombic is also called as what? Alpha sulfur. monoclinic is also called as beta sulfur. Okay, alpha sulfur and beta sulfur, alpha beta, and this can be called as prismatic sulfur. Okay, prismatic sulfur. Okay, so please remember that point. And you all know that sulfur exists as octaatomic element, octaatomic S8. Okay, and it has crown shaped structure, crown shaped. Okay, sulfur will be existing as what? Octaatomic element. Okay, sulfur and even selenium also. Both are what? Octaatomic elements with crown shape. Okay, with crown shape. Please remember that point. Okay, that means all the sulfur, 8 sulfur atoms are in the form of a crown shape. Okay, so this you might have learnt even in your lower classes also. Then if you go for sulfur properties, if you go for, okay, generally properties of sulfur, if you go for, it's a pale yellow colored liquid. Okay, rhombic sulfur, rhombic sulfur is a pale yellow colored liquid. Okay, and it is insoluble in water and soluble in carbon disulfide. It's a another solvent, CS2, soluble in CS2, soluble in what? CS2. What is CS2? Carbon disulfide. It is insoluble. Generally rhombic, not only rhombic, all types of sulfurs are what? Insoluble in water. Okay, because water is what? Polar solvent, whereas it is soluble in what? Soluble in carbon disulfide. Okay, soluble in carbon disulfide. Okay, CS2. CS2 is an organic solvent. Okay, and generally you will find it is having a high melting point, 385.8 K. Melting point of rhombic sulfur is what? 385.5 Kelvin. Okay, it's having high melting point. Generally if you are heating sulfur, okay, it melts, it catches fire and it burns with the blue colored flame. Generally you take, not only I am speaking about rhombic, generally about sulfur. Okay, sulfur burns with what? Blue colored flame. Sulfur is which colored? Actually pale yellow colored. Pale yellow colored sulfur. It looks like Complan Kesar Badam. Okay now, because all of you know about Complan Kesar Badam. Okay, how it looks, pale yellow colored powder, isn't it? So same like that, sulfur powder also looks like pale yellow color. Okay, Complan Kesar Badam color. Sulfur pale yellow color burns with what? When you are keeping that sulfur on a flame, it burns with blue colored flame. It burns with blue colored flame. Okay, it burns with what? Blue colored flame. Okay, and it produces sulfur dioxide gas. SO2 gas is released. Okay, that SO2 gas is colorless actually. SO2 gas is colorless gas. Okay, SO2 gas is colorless gas. Okay, and causes lot of suffocation also. Suffocation will come, sulfur dioxide. And sulfur dioxide is highly acidic in nature. Please remember, sulfur dioxide is what? Highly acidic in nature. That's why it turns what? Blue litmus paper to red. If you are exposing these vapors of sulfur dioxide, when they are exposed to a blue litmus paper, okay, so it turns immediately blue litmus to red. Blue litmus paper when exposed to sulfur dioxide, okay, it turns to red, which shows that sulfur dioxide is what? Acidic in nature. Okay, highly acidic in nature. Okay, and sulfur dioxide, if you are exposing blue litmus, I just told you the change in the color. Okay, if any vegetable coloring matter, please remember this point also, sulfur dioxide. Now I am telling you about what? Sulfur dioxide. If any vegetable coloring matter, okay, SO2, okay, when exposed to vegetable coloring matter, okay, vegetables or colored flowers, okay, vegetable coloring matter if it is there. Okay, then it makes it colorless. Sulfur dioxide makes the colored vegetables to become colorless. Okay, makes it colorless. Okay, why? Because it acts as a good dehydrating agent. Please remember that point also. Okay, suppose what I am going to say is sulfur dioxide, when it is when any colored flowers like red rose or yellow rose or any colored vegetables like carrots, beetroots, if you are exposing them to sulfur dioxide, okay, then the color of that carrot or beetroot will get faded away. Please remember that point. Okay, it makes it colorless. Carrot become colorless. Carrots, beetroots, all these becomes colorless. Okay, becomes colorless when exposed to what? Sulfur dioxide gas. Becomes colorless when exposed to sulfur dioxide gas. Okay, so why it is like that? When exposed to sulfur dioxide, why it is like that? Because sulfur dioxide acts as very good bleaching agent. Acts as a very good bleaching agent. What is bleaching agent? It bleaches the vegetable coloring matter which is there in sulfur, which is there in vegetables or in colored flowers and all. Okay, very good bleaching agent. Okay, or in other words, you can even call it as what? Dehydrating agent. Sulfur dioxide acts as what? Very good dehydrating agent. Dehydrating, D, the word DED stands for what? Removal. Removal of hydrating molecule means what? Water molecule. Water molecule gets removed away from that vegetables or colored flowers. That's why they get bleached off. Means what? They rendered to be colorless. Okay, they becomes colorless. Okay, so that's why sulfur dioxide acts as what? A very good bleaching agent. Okay, so here you will be getting the next compound. The first compound of sulfur I told you. Okay, sulfur, if you are burning it, sulfur dioxide, if you are burning it in excess of oxygen, 2SO2 plus O2 gives rise to 2SO3. Sulfur trioxide you will get. Sulfur trioxide is also highly acidic in nature. Okay, it's a non-metallic oxide. That's why it is highly acidic in nature. Okay, this sulfur trioxide, when made to react with water, you will be getting what? H2SO4. Okay, H2SO4. What is H2SO4? Sulfuric acid. Okay, sulfuric acid. And this is the process which is called as what? Contact process. Contact process. You call it as what? Contact process. Okay, so here generally the catalyst used is vanadium pentoxide. Okay, in presence of V2O5. Okay, vanadium pentoxide, V2O5 acts as catalyst. That means what is catalyst? Catalyst is a substance which is used to speed up the rate of a reaction. Okay, now catalyst is a substance which is used to speed up the rate of a reaction, contact process. Okay, in that contact process, SO3 reacts with water in presence of vanadium pentoxide as catalyst. Okay, it forms what? Sulfuric acid. This process you call it as what? Contact process. Okay, so like this you will be getting certain compounds. Compounds of what? Sulfur. Okay, so here I told you about sulfuric acid. So you have not only sulfuric acid, you have lot many oxy acids are there with sulfur. That is very much important regarding sulfur. Please remember this point, oxy acids of sulfur. Please take down this very important question. You will be getting question only on this area. Oxy acids of what? Sulfur. What are the different oxy acids of sulfur? That you have to learn now. Okay, so this is a very important area which you have to cover. Okay, so what are the different oxy acids of sulfur? Okay, let us learn now. First point in this, you just take down oxy acids with SS linkage. Oxy acids with sulfur single bond sulfur. This linkage if it is there. Okay, oxy acids with SS linkage. SS linkage are called as thioacids. Okay, SS linkage are called as what? Thioacids. Please remember, thio. The word thio we will use. Okay, for oxyacids. Okay, oxyacids with the lower oxidation states. Acids with the lower oxidation state. Lower oxidation state. Acids with the lower oxidation state. Okay, are generally termed as OUS with the suffix OUS, us acids. Okay, with the higher acids with higher oxidation states are termed as what? Acids with a higher oxidation state. OS I am writing. Higher oxidation state are termed as ic acid. Okay, now ic acids. Okay, so let us learn examples. Okay, so first let us learn examples of us acid series. Us acid series. What are sulfurous acid? Like that, us acid series. Okay, so in that first one is what? Sulfurous acid, H2SO3. Sulfurous acid. Okay, now sulfurous acid is what? H2SO3. Here sulfur will have what? +4 oxidation state. OS is +4. Please remember, OS I am writing, that is oxidation state. Okay, and next second one, thiosulfurous acid. Thiosulfurous acid. Okay, now thiosulfurous acid, that is H2S2O2. H2S2O2. And here oxidation state of sulfur is +1 OS. Oxidation state of sulfur is how much? +1. Okay, so like that you have ic acids are also there. Okay, like how I told you about sulfuric acid. Okay, so oxy acids with IC as a suffix, ic acids, us acids and ic acids. Okay, so us acids, sulfurous acid and thiosulfurous acid. You can even have hyposulfurous acid. Just take down the third one. Hyposulfurous acid. Okay, now hyposulfurous acid. For this H2S2O4. H2S2O4 and sulfur will have +3 oxidation state in this. Okay, now oxidation state of sulfur is +3. Please remember. And next you have fourth type of OUS, us acid is pyrosulfurous acid. Pyrosulfurous acid. Pyrosulfurous acid. You have for this formula is what? H2S2O5 with +4 oxidation state. Okay, oxidation state of sulfur is how much? +4. Pyrosulfurous acid. So these four are what? Us acid series. Okay, then we go for ic acid series. Ic acid series. These all are called what? Oxo acids of sulfur. Okay, you will be getting, there are more chances for you to get question in this area only. Okay, ic acid series. So first one you know it is sulfuric acid. Okay, sulfuric acid. Oxidation state of sulfur is how much? +6. H2SO4. You know that sulfuric acid is what? H2SO4. Okay, and then thiosulfuric acid, H2S2O3. Thiosulfuric acid. Okay, now thiosulfuric acid is H2S2O3. Here also you will find a +6 oxidation state for sulfur. And next third one, in ic acid series, you have pyrosulfuric acid, H2S2O7. Pyrosulfuric acid. Pyrosulfuric acid, which is H2S2O7. Okay, H2S2O7. Here also you will find what? Like the other compounds. Sulfur is having what? +6 oxidation state. Okay, now sulfur is having +6 oxidation state. Okay, next you have other type of acids are also there. Please concentrate on these points. Okay, you will be getting objectives from these points. Okay, please remember. Right? Next, thionic acid series. Third type are what? Thionic acid series. Okay, thionic acid series. So what are those? Dithionic acid is there. Dithionic acid. Okay, H2, S2, O6. Here oxidation state of sulfur is how much? +5. Dithionic acid, H2S2, O6. And next, polythionic acid means what here? In place of di, if you are keeping N, in place of di you are keeping 2 here. If you are keeping N, then you will call it as what? Polythionic acid. Polythionic acid, H2SnO6. Okay, now H2SnO6, polythionic acid. Here N value can be anything like 3, 4, 5, 6 like that. Okay, so remember that point. N value can be, it can be 3, 4, 5, 6 and so on. Okay, and next we have peroxy acid series. Peroxy acid series. So what are peroxy acid series? So first one is peroxy monosulfuric acid. Please remember peroxy, the word stands for what? Peroxy bond is the type of bond which is in which oxygen and oxygen are linked with a single bond. Peroxy bond, you call it as what? Peroxy bond. Okay, so here first in peroxy acid series, first one is what? Peroxy monosulfuric acid. Peroxy monosulfuric acid. Okay, peroxy monosulfuric acid, formula is H2SO5. Here oxidation state is +6. Okay, and you call this as Carros acid. Okay, you call this as what? Carros acid. And next you have peroxy disulfuric acid. Peroxy disulfuric acid. Okay, which is called as what? Marshall's acid. Okay, H2S2O8, you call it as oleum. Okay, or Marshall's acid. Marshall's acid. Okay, H2S2O8, which is called as what? Marshall's acid. Here also oxidation state of sulfur is how much? +6 only. Okay, so here peroxy bond will be there. That means what? Oxygen will have single bond linkage will be there. Okay, then you call that as what? Peroxy bond. That's why this series of acids, you call them as what? Peroxy acid series. Okay, so like that you have different types of oxo acids are there for what? Sulfur. Okay, so this is all about the important points. Up to now we have learnt only 6 A group elements. Okay, now we have to move on to what? 7th A group elements, which are called as what? Halogens. What are 7th A group elements? Halogens. What are those elements? Yes, fluorine, chlorine, bromine, iodine, astatine are called as what? Halogens. 17th group elements. Okay, now 17th group. What are the 17th group elements? Fluorine, chlorine, bromine, iodine, astatine. These elements are called as what? 17th group elements. Also called as 7th A group elements. You call them as what? Halogens. Okay. This halo, the word halo stands for what? Seawater. Gens stands for born from. That means these all elements are born from seawater. Okay, born from seawater. Okay, please remember. Okay, and they have general configuration how much? NS2, NP5. All these are what? Monovalent gases. Please remember, monovalent gases. NS2, NP5. So total number of valence electrons are 7 and their valency is 1. Monovalent. Valency is 1. Okay, these all are what? Non-metals. Okay, so in that non-metals you will find fluorine and chlorine in the form of gases. Okay, non-metals. All are non-metals only. And bromine is a liquid non-metal. Bromine exists in the form of liquid. Iodine and astatine are can exist in the form of solids also. Astatine is a radioactive metal. Okay, it exhibits metallic character. I already told you down the group, bottommost element is a metal. Okay, so please remember that point. Valency is 1. That's why they are called as monovalent. If you go for the atomicity is 2. That means what? They are by a diatomic molecule will form with them. Like they form F2, Cl2, Br2, I2 type of molecules they form. Okay, diatomic molecules. That's why their atomicity is how much? It is equal to 1. Okay, atomicity is equal to 1. Okay, so like that you have a certain what we call general properties. Okay, so general properties are what? We go for general properties like periodic properties like atomic radius increases down the group. Okay, electropositivity will be actually the bottommost element is a metal. That's why electropositivity is actually less for these elements because they have the tendency to gain electrons. So electronegative elements you are finding here. Okay, because all these are what? Non-metals. Okay, fluorine, highest electronegative element. And chlorine is highest electron affinity element. Okay, highest electron affinity, element with highest electron affinity. Okay, please understand what is the difference between electronegativity and affinity. Electronegativity is tendency to attract the shared pair of electrons in a bonded atom. Okay, from the bonded atom, the shared pair of electrons will be attracted by that particular element. Fluorine is highly electronegative, whereas chlorine is highly electron affinity element. Means what? It has a tendency to attract an electron but not the shared pair. Okay, tendency to attract an electron but not the shared pair in bond. The one which is attracting the shared pair of electrons in bonded atom, you call it as more electronegative. Okay, so electronegativity is the tendency which is observed in a bonded atom, whereas electron affinity is the tendency which is observed in normal elements. Okay, not in a bonded atom. Please remember that. Okay, so you are finding highest electron affinity elements, highest electronegativity elements in 7th A group. Okay, so if you go for their properties, okay, generally they are colored compounds. Colored compounds they will form. Okay, colored compounds like if you go for fluorine will form yellow colored compounds. Okay, fluorine F2, not the movie. Okay, it's I'm not speaking about movie. F2 yellow colored compounds they will form, and chlorine Cl2 greenish yellow colored compounds it will form. Flame color also the same thing, greenish yellow colored compounds. Okay, it will form. Chlorine forms greenish yellow colored compounds, and bromine water. Okay, now bromine Br2, it will form what? Reddish brown colored compounds it will form. Br2, reddish brown colored compounds. Even bromine also, bromine water appears to be what? Reddish brown in color. Okay, reddish brown colored compounds. And iodine vapors, if you might have seen iodine vapors, they will be appearing as violet colored vapors, violet ash you will find if you are burning iodine crystals. Violet colored compounds iodine will form. Okay, so like that they have the tendency to form what? Colored compounds. Okay, and then fluorine and chlorine are soluble in water, whereas bromine and iodine are soluble in even in other solvents also. These two are what? Soluble in water soluble. Okay, fluorine and chlorine are what? Water soluble, whereas iodine and bromine can be soluble in other solvents other than water also, other organic solvents. Okay, now if you go for other organic solvents like what? Carbon tetrachloride, benzene. Okay, even bromine and iodine can be soluble in can be soluble in other organic solvents also. Okay, other organic solvents. Okay, other organic solvents like what? Like CCl4. Carbon tetrachloride is an organic solvent. Okay, benzene, C6H6, benzene is a organic solvent. So in such kind of solvents also bromine and iodine can be soluble, whereas fluorine and chlorine are soluble only in water. Okay, so please remember that point. Okay, next if you go for the other properties. Okay, if you go for the other chemical properties or other general properties, if you go for, okay, they exhibit -1 oxidation state. You all know that generally fluorine, if you go for, exhibits -1 oxidation state. In most of its compound, it exhibits -1 oxidation state. OS I am writing. OS means what? Oxidation state. Okay, and they can also exhibit, even other elements can exhibit +1, +3 and +5 oxidation states also. +1, +3 and +5 oxidation states in different compounds you can see. Okay, they can even exhibit +1, +3 and +5 oxidation states also. Okay, so in different types of compounds you will find different oxidation states. Okay, so +1, +3 and +5 oxidation states also. Okay, so these elements are highly reactive and the reactivity increases down the group. Okay, reactivity increases down the group. Reactivity increases down the group. Okay, please remember these points. Reactivity of fluorine, chlorine, bromine, iodine increases down the group. Okay, acidic strength of these acids, they form acids like HF. Okay, acidic strength, if you go for acidic strength, okay, HF is less than HCl, is less than HBr, is less than HI. Okay, HI. So this will be the acidic strength of their acids. Okay, and if you go for stability of oxides, oxides of iodine are more stable than chlorine. Oxides. Okay, stability of oxides. Stability of oxides. Okay, for iodine, they form more stable oxides. Then comes bromine, then comes chlorine. Okay, oxides, stability of iodine oxides are more stable than first chlorine will be more stable, then bromine exists in the form of water, I mean liquid. Okay, so bromine water is, oxide of bromine water is less stable than oxide of chlorine. Oxychlorides you will find, isn't it? Chlorine, when you form oxides of chlorine means oxychlorides. Okay, oxy acids of halogens also you will be learning, like how we have learned for oxy acids of sulfur, same like that oxy acids of halogens also we will learn now. Okay, so like that oxides stability is more for iodine oxides, and then for, okay, and next if you go for oxides of fluorine, especially you have to learn about OF2 and O2F2. Okay, oxides of fluorine, oxides of fluorine are what? OF2 and O2F2. Dioxy difluoride is O2F2, oxyfluoride is OF2. So in these two oxyfluorides, oxygen exhibits what? +1 and +2 oxidation states. You just see fluorine if you keep -1, oxygen if you keep X, oxidation state of oxygen if you keep X here. Okay, so 1 into X plus 2 into -1, it's a compound, so you are equating the oxidation number to find the oxidation number, you are equating to 0. Okay, so x minus 2 is equal to 0, x equal to plus 2. That means oxygen is exhibiting plus 2 oxidation state in OF2 molecule. Oxygen exhibiting plus 2 oxidation state in OF2. Same like that, it exhibits plus 1 oxidation state in O2F2. Okay, if you go for O2F2, fluorine minus 1 you will keep, oxygen x you will keep. So 2 into x plus 2 into minus 1 is equal to 0. 2x minus 2 is equals to 0, which implies 2x is equal to 2. That means oxidation number of oxygen, you will find it to be plus 1. Okay, so oxygen exhibits positive oxidation states. Okay, now positive oxidation states. Positive oxidation states. Oxygen exhibits positive oxidation states. Write this point. Oxygen exhibits positive oxidation states in oxides of fluorine, in OF2 and O2F2. This is very important point you will be getting. Oxygen exhibits positive oxidation states in compounds of fluorine. Okay, OF2 and in O2F2 it forms positive oxidation states. Okay, so this is regarding oxidation number of oxygen and fluorides of oxygen. Okay, and next we go for ionic character of metal halides decreases down the group. Ionic character, metal halides if you go for, okay, metal halides, ionic character decreases down the group. Okay, note, this is also one important point you have to remember. Ionic character of metal halides, ionic character of metal halides decreases down the group, decreases down the group. Okay, that means what? Metal halides, like if you take M, okay, M is a metal, okay, then MF, okay, metal halide, okay, metal halide, it will be of what form? MF, okay, NAF, MgF, MgF2, like that, anything. It can be of M2F, MF2 form or MF form, anything it can be. Metal, M stands for metal. Okay, ionic character decreases, then fluorine, MF will have more ionic character, then comes MCl, then comes MBr, then comes Mi. Okay, this is more ionic. M stands for a metal, please remember, more ionic, whereas Mi is less ionic. You have learnt about these points even in Fason's rule. In chemical bonding also we have learnt about metal halides. Okay, metal halides, please remember, ionic character of metal halides decreases down the group. Okay, ionic character decreases down the group. Okay, ionic character decreases down the group. Okay, this point also please remember. Okay, next if you go for compounds of chlorine, compounds of what we call other halogens and all. Okay, so compounds of chlorine, if you go for, so many compounds will be there. Okay, like sodium chloride is there. Okay, sodium chloride, ionic compound, their properties and all. HCl is there, acidic properties will be there. Okay, so preparation properties and what we call chlorine compounds. Okay, in that bleaching powder also will be there. Okay, CaOCl2, it is one of the important compound of chlorine, please remember, compounds of chlorine. Okay, bleaching powder, calcium oxychloride, CaOCl2 is called as what? Calcium oxychloride is called as what? Bleaching powder. It is one of the important compounds of what? Chlorine. Okay, which is generally used in swimming pools and all as a disinfectant. Okay, and preparation properties and all once you go through this. Okay, so in this preparation and properties you will be getting less number of questions. You will not get more questions. Okay, and you have a poisonous gas is formed with chlorine. Okay, poisonous gases like what? Phosgene. Phosgene is a poisonous gas. Okay, phosgene, please remember, in compounds of chlorine, phosgene. Phosphine is different, phosgene is different. Phosgene is a poisonous gas which is COCl2. Okay, COCl2 is called phosgene gas, and you have even other poisonous gases like what we call phosgene is also there, as well as tear gas is also there. Tear gas, CCl3NO2, tear gas. Yes, tear gas is what? CCl3NO2 is called as tear gas. Okay, so like that, certain disinfectant compounds can be made with the help of what we call chlorine. Okay, so just go through that all. Okay, and you have even mustard gas also is there, C2H4S, C2H4ClCl, C2H4S, C2H4S, C2H4, on both sides ClCl. This is called as what? Mustard gas. Mustard gas. Okay, so like that, certain important gaseous substances are formed with chlorine. Just go through them. Okay, and certain preparation and properties, okay, of certain compounds of chlorine. Please go through that also. Okay, next. Okay, next if you go for HCl. HCl, important compound of chlorine is what? HCl, hydrogen chloride. Okay, HCl is a very important acid. It's a very powerful acid which you already have learnt about it. Hydrochloric acid. Okay, so hydrochloric acid is a very important compound of what? Chlorine. Okay, how it is prepared? When NaCl reacts with H2SO4, it forms HCl. Okay, NaCl reacts with H2SO4, it forms Na2SO4 and HCl. Okay, Na2SO4 and HCl. Like this, HCl can be prepared in the laboratory preparation if you go for. Okay, and if you go for the boiling point, okay, boiling point is 189 BP, boiling point is 189 Kelvin. Okay, boiling point is how much? 189 Kelvin, and freezing point is 159 Kelvin. Okay, freezing point is what? 159 Kelvin. Like that, you have certain properties are there. Okay, and in this you will find mixing of 3 parts of concentrated HCl, 3 parts of concentrated HCl and 1 part of concentrated HNO3, 1 part of concentrated HNO3. This mixture is called as aquaresia. Aquaresia. This mixture is called as what? Aquaresia. Okay, this mixture can dissolve noble metals like gold, platinum, can be dissolved in this aquaresia. Can dissolve noble metals. Can dissolve noble metals like what? Can dissolve noble metals like gold, Au, gold, platinum, okay, mercury can be dissolved in aquaresia. Okay, so like that, you have certain important points regarding what? HCl. Okay, so uses of HCl as a laboratory reagent for making for extraction of glues and all. Okay, that all you just go through. And finally, we have to, in this 7th A group elements, we have to learn about oxyacids of halogens. Okay, now oxyacids of halogens and interhalogen compounds. It's a very important topic you have. Okay, so please focus on this area. Okay, what I'm going to tell you next, oxyacids of halogens. Okay, so next you please keep side heading. Okay, oxyacids of what? Halogens. Halogens are what? oxyacids of halogens. Okay, so oxyacids of halogens means halogens when react with any acid, you will be finding certain oxyacids of halogens. Okay, so in that different categories are there. First we will write about hypohalous acids. Hypohalous, here halous means if it is if hal, hal word stands for chlorine, bromine. Okay, hypochlorous acid, like that. Here halous is a general word I am using here, where hal, the word hal stands for a halogen. Okay, hypohalous acids. Okay, so they have what? General formula is HOX. Okay, hypohalous acids, general formula is HOX. Like you have HOF, HOCl, hypochlorous acid, hypobromous acid, HOBr, HOI. Okay, so in all these hypohalous acids, oxidation state of halogen OS is +1. Oxidation state of halogen, whatever halogen which is present in that hypohalous acids, oxidation state of halogen is how much? +1. Please remember. So next we will go for the second type, halous acid HXO2. Halous acids HXO2. Okay, general formula is what? HXO2. Okay, example is HClO2. Examples are what? HClO2. Okay, halous acid, chlorous acid, this is HClO2 is what? Chlorous acid. Okay, HBrO2. In this you will find oxidation state of halogen is +3. Okay, so such kind of acids are called as what? Normally halous acid, it means chlorous acid, bromous acid, like that you have to read. And for them oxidation state is how much? +3. Okay, and next we go for halic acids. These are halous acid where us, the word us stands for what? Less oxidation state. If ic is there, it is for what? More oxidation state. You have to remember like that. Halic acids. Okay, now next comes what? Halic acids. Okay, HXO3 will be there. For them general formula is what? HXO3, halic acids. Okay, so examples for halic acids are what? HClO3, HBrO3, chloric acid. Okay, perchloric acid. You call it as what? HClO3 is what? Perchloric acid. Perbromic acid, HBrO3, HiO3. Okay, so in all these compounds, what is the oxidation state of halogen? It is +5. Oxidation state is +5. I told you, no, if oxidation state is less, you will use the suffix as. If oxidation state is more, you will use the suffix ic. Halic, +5 oxidation state. Halous, +3 oxidation state. As is for less, ic is for more oxidation states. Okay, please remember that point. And next you have perhalic acids. Okay, perhalic acids. Perhalic acids. Okay, HXO4. Perhalic acids, HXO4. Like you have HClO4. Okay, HClO4, HBrO4, HiO4, like that. Here you will find oxidation state to be +7 oxidation state. As I already told you, they can exhibit oxidation states of +3, +5 and +7. Okay, so like that you have different types of oxyacids of halogens are there. Okay, so these are the different areas which you have to focus in case of what? 7th A group elements. Okay, this is about halogens. And finally we move on to 8th A group elements, which are called as what? Inert gases. finally we are moving on to 8th A group elements. Okay, 8th A group elements, which are called as what? Inert gases. Okay, they have general configuration NS2, NP6 except for helium. Except for helium. So what are the elements which are there in 8th A group? Once check. Helium, neon, argon, krypton, xenon and radon. These elements are called as inert gases. So here helium is atomic number 2. It has electronic configuration N1s2. And this configuration you call it as duplet configuration. Whereas for all the other elements from neon to radon, you have general configuration is Ns2 Np6, which is called as octet configuration. Okay, they have 8 electrons in their valence shell. They have octet configuration is there. Ns2 Np6 octet. Okay, so like this octet only makes them more stable. Octet configuration makes the element to be more stable. Stability is based on what? Octet rule. You have learnt. All other elements of a periodic table try to attain stability by acquiring octet configuration as set of these inert gases. So because of the presence of octet configuration, these inert gases are said to be what? Highly stable. Okay, so more stability will be there for inert gases. Okay, why they are said to be inert? They all are monoatomic gases. Okay, they don't have these all periodic properties. Generally, if you go for atomic size, down the group atomic size increases, that you know. Okay, inert means they are highly inactive. Okay, they are highly what? Inactive, inert. Okay, they don't react with other elements. Okay, except xenon. Okay, no other element is going to form compounds. Okay, xenon is the only inert gas which can form compounds. Okay, we'll discuss that compounds also. Okay, so if you go for the general properties like atomic size increases down the group. Okay, they have high ionization energies. It is very difficult to remove electron from the valence shell of these inert gases. Okay, atomic size increases down the group. Okay, and ionization energy. Okay, high ionization energies will be there, very high, because they already has octet configuration. If you want to remove an electron from that stable elements, will they lose electron easily? Is it easy to take out electron from the valence shell of inert gases? It is very difficult because they are already stable. They got octet configuration. So you cannot remove electron. Ionization energy means what? The energy required to remove electron from the valence shell. Okay, so it is very difficult. Ionization energy for inert gases is very high. Okay, and if you go for electronegativity, okay, electropositivity, these all properties are actually they doesn't want these properties. These all properties are meant for what? Meant for other elements which are trying to acquire stability as that of these inert gases. But these are, because of octet configuration, they are already stable. Okay, so all these properties are actually we need not to study about the properties like that. Okay, so if you go for if you go for certain other properties, as I told you, they are monoatomic and they are easily soluble in water. Monoatomic. Inert gases are what? Their atomicity is 1. They are easily soluble in water. Okay, now they are soluble in water. I am not saying that they are insoluble. Their reactivity is less, but their solubility is high only in water. Okay, solubility is high in water. Okay, and they are least reactive, as I told you. Okay, because of octet configuration. Okay, and then we have to go for what? Xenon fluorine compounds. Okay, compounds of xenon. This is very important point. Here this inert gases, we don't have much information, but you will have to focus on compounds of xenon. Okay, just focus on these compounds of xenon, that will be highly enough for you. Okay, so xenon is the only element which can, only inert gas which can form compounds. Okay, so it can form compounds with fluorine. Okay, with fluorine it can form compounds, and it can also form compounds with oxygen. Okay, xenon compounds with oxygen and xenon compounds with fluorine. First, if you go for xenon compounds with fluorine, okay, it forms three types of fluorides will form. XeF2 will form. Okay, XeF4 it can form, and XeF6 also it can form. With the fluorine, it can form three types of compounds. Okay, with fluorine, xenon can form three types of compounds: XeF2, XeF4 and XeF6. Three types of compounds. Okay, so if you go for XeF2, you have learnt even these all compounds even in chemical bonding also. You can just recall them. Okay, so if you go for XeF2, XeF2 will have sp3 dehybridization will be there. Okay, if you go for the structure, okay, xenon means it will have 8 valence electrons will be there. So with the 2 fluorines, it will form 2 bonds like this, and you will be left with 3 lone pair of electrons are there. Okay, now, so 2 sigma bonds and 3 lone pairs of electrons are there. Total is 5. So if total is 5, it is sp3 dehybridization. Here shape is what? Linear. For XeF2, shape is linear. Bond angle is 180 degrees for XeF2, first compound. Okay, same like that if you go for XeF4. Okay, so same compound. If you go for XeF4, okay, so see, look at the structure. Or xenon will have 8 valence electrons. Okay, so with the 4 valence electrons, it forms 4 bonds. 4 fluorines will form 4 bonds. So how many electrons are left over here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2 electron pairs are left over. Okay, 2 electron pairs are left over. That means it is forming 4 sigma bonds and 2 electron pairs, 2 lone pairs are there. 2 LPs. So 4 plus 2 is 6. So if it is 6, the hybridization is how much? sp3 d2. 1s, 3p and 2d. sp3 d2. And the shape of this molecule is what? The shape of this molecule is square planar structure. Square planar structure. Okay, XeF4. Okay, now same like that if you go for okay, now if you go for the third compound, that is XeF6. Okay, XeF6. So with the 6 electrons, 6 fluorines it will form. XeF6. Okay, it will have with the 6 fluorines, like if you go for up 1, down 1 fluorine. Okay, and then fluorine, 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 fluorine. Totally 6. Okay, it is like this. You will find the structure of XeF6 like this, and it is left with what? 1 lone pair of electron. It is left with 1 lone pair of electron also. It is there. So here how many totally? 1, 2, 3, 4, 5, 6 sigma bonds plus 1 lone pair will be there. So total is 7. So hybridization is what? sp3 d3 hybridization. And the shape of this is what? Distorted octahedral shape. Because of the presence of lone pair, you will find the shape of XeF6 is what? Distorted octahedral. Okay, now distorted octahedral shape you will find. Okay, distorted octahedral. So these are the compounds of xenon with fluorine. Okay, same like that it can form compounds with oxygen also. Xenon can form compounds with oxygen also. So what are the compounds formed with xenon with oxygen? XeO3 is there. Okay, XeO3, xenon trioxide. Okay, and XeOF4, xenon oxy tetrafluoride, XeOF4. Okay, so if you go for xenon trioxide, xenon is having what? 8 valence electrons. Okay, so with 3 oxygens, it forms 3 double bonds. It will form. Xenon will form 3 double bonds with 3 oxygens, and it is left with 1 lone pair. So here you are finding 3 sigma bonds plus 1 lone pair will be there. In here double bonds are there, but you have to count what? Only sigma bonds which are there with the central atom. Okay, so 3 sigma bonds and 1 lone pair is there. So total is 4. If it is 4, you call it as what? sp3 hybridization. sp3 hybridization with 1 lone pair is, the shape will be what? Pyramidal shape. So for XeO3, the shape of the molecule is what? Pyramidal shape. Okay, and XeOF4. For XeOF4, second compound. This is first compound which I have drawn here, and the second compound is what? XeOF4. Okay, xenon oxy tetrafluoride. Okay, so xenon is having what? 8 valence electrons will be there. With 4 fluorines, it forms 4 bonds. Okay, like this. With 4 fluorines, it forms 4 bonds. It will form. Okay, and with 1 oxygen, it forms double bond. Okay, oxygen, with 1 oxygen, it forms double bond. Okay, now 1 lone pair of electron is left over. Okay, 1 lone pair of electron is left over. Okay, so here how many sigma bonds you are finding? 4 sigma bonds. Sorry, 1, 2, 3, 4, 5 sigma bonds you are finding. Even in this double bond also, you will find 1 sigma bond. So totally 5 sigma bonds and 1 lone pair of electron you are finding. So total is 6. If total is 6, the hybridization will be what? sp3d2. sp3d2 hybridization. 1 plus 3, 4, 4 plus 2, 6. So sp3d2 hybridization will be there. Okay, for this the shape is what? Square pyramidal shape. Okay, square pyramidal shape. Okay, so like this you have certain important structures and all you have to go through in case of what? Inert gases. Okay, so please go through the preparations and properties also once you have a look on to them. Okay, then it will be easy for you. Okay, focus on all these points. I gave all the points which are there for 16th, 17th and 18th group of elements all together in one shot. Okay, most of the questions which are being covered for your previous EAMCET are being covered in these points only. Okay, don't think that ma'am has not given questions and answers type. Okay, please, if you are thorough with the concept, then automatically what I discussed here, okay, will be exactly coming like that only in the exam. If you are focusing on these areas, it will be highly enough for you, my dear children. Okay, so please kindly write and practice, make notes on your own. Okay, kindly make your own notes of what all your teacher says. Okay, keep referring that notes and that will be highly enough for you. Class of 1.5 hour, if you are spending fruitfully by watching the whole video, okay, without skipping it, if you watch the whole video, then it will be very much beneficial for you, my dear children. Okay, so I always say your hard work is your superpower. Thanks for watching. Bye.
If you like this video, just like and subscribe the channel and share this video.